Hello and welcome. Today in this video, we will discuss Z-transform. Z-transform. Z-transform is used to analyze discrete time signals and systems. Definition of Z-transform is x of z is equal to n varies from minus infinity to plus infinity x of n z raised to minus n. This Z-transform is also called as a bilateral Z-transform as limits are minus infinity to plus infinity, where this Z is a complex quantity and it is expressed in a polar form r e raised to j omega. Now, whenever we will take Z-transform, one more concept we should keep in mind, that is region of convergence, ROC. There are some properties defined about the ROC of Z transform. Let's see what is this ROC. ROC defines the region where Z transform exists. Means what? This is a definition of Z transform. X of Z is equal to n varies from minus infinity to plus infinity x of n z raised to minus n. Z transform exists means this x of z should have some finite value. It should have less than infinity. We should get some finite value of x of z. It can be also defined as the ROC of x of n means the range of z for which z transform converge. That is, this x of n z raised to minus n is absolutely summable. And we can express this like this. That is, this n varies from minus infinity to infinity. X of n z raised to minus n. It should be absolutely summable, means its value should be less than infinity. We should get some finite constant value. This is about ROC. Now let's solve one example so that you can understand how to apply the definition of Z transform and how to find its ROC. Now question is, find the Z transform of a sequence x of n is equal to 1, 2, 3, 4. Here, what is the position for n is equal to 0? The position has not mentioned here, means by default the first sample represent n is equal to 0 amplitude. That means your sequence is like this. N is equal to 0, amplitude is 1, this one. N is equal to 1, amplitude is 2. N is equal to 2, amplitude is 3. And n is equal to 3, amplitude is 4. So this is our sequence. We want to take the Z transform of this sequence. Definition of Z transform is x of z is equal to n varies from minus infinity to plus infinity x of n z raised to minus n. Let's put the limits for x of n or n, and for that we should check what is the existence of x of n. X of n exists from 0 to 3. N is equal to 0 to 3. For other values of n, x of n is not there, means it is 0. That means this limit n varies from 0 to 3 for x of n. So, n is equal to 0 to 3, x of n, z raised to minus n. Now, we can put the values of n. N is equal to 0, 1, 2, 3. Let's start. N is equal to 0. X of 0, z raised to 0, minus 0. X of 1, n is equal to 1. X of 1, z raised to minus 1. X of 2, z raised to minus 2. X of 3, z raised to minus 3. Now put the value of x of 0, x of 1, x of 2, x of 3. That is 1, 2, 3, 4. X of 0, 1, z raised to 0 is 1. Then 2, z raised to minus 1. X of 2 is 3, z raised to minus 2. X of 3 is 4, z raised to minus 3. Now this is our x of z. What about the ROC? ROC tells us that x of z should have some finite value. Now we can check for which value of z, x of z is finite. and for which value of z, x of z becomes infinite. If you will check here, if I put z is equal to 0, 1 upon 0 is infinite. So for other values of z, x of z is finite, but only for z is equal to 0, this x of z becomes infinite. That means the ROC of this sequence x of n is entire z plane except z is equal to 0. Now how to draw it graphically? Our ROC is entire z plane. So this is a z plane, real axis and imaginary axis, as z is a complex quantity. It has some real part and imaginary part. Now your ROC is entire z plane, means complete z plane. But how to show this except z is equal to 0? We'll here draw a circle, field circle, to indicate that entire z plane except z is equal to 0. Z is equal to 0 is at the center part. So this is the ROC of our sequence. And based on that, first property of this ROC of Z transform is, if x of n is finite duration right-sided sequence, then the ROC is entire z plane except z is equal to 0. Let's understand. X of n is finite duration. Finite duration means it has some particular samples. It doesn't exist from up to infinity and from minus infinity. It has some finite samples. In our sequence, there are 4 samples. 1, 2, 3, 4. That means it is finite. Then right sided. You can check our signal exists from n is equal to 0, 1, 2, 3. It is right side. It exists from right side. If your signal exists at n is equal to minus 1, minus 2, then it is left side. Now our sequence starts from 0 to right side only. That's why finite duration right sided. Finite duration 4 samples are there. Right sided because this signal exists n is equal to 0 onwards. For this type of sequence, ROC is entire z plane except z is equal to 0. So this is how we take the Z transform and find its ROC. Thank you.